There's a new cancer vaccine. Now, I say new, it came out in the public where they made a story about it, okay? And it's for triple negative breast cancer, okay? If you look at all cancers in general, the most studied and the most funded cancer is breast cancer. And so, they've made huge strides in treatment and protocols and things of that nature for people, obviously women. Now, guys get breast cancer too, but obviously 98% of them are all going to be female. And so this particular article was about cancer vaccine that's in phase 1 trials at the Cleveland Clinic. And it's interesting to note that it's in phase 1. So they only used it's in human trials now, but they only used a small segment of the population, and they focused strictly on triple negative breast cancers. That's the most aggressive breast cancer out there. People may kind of recognize that by Angelina Jolie. She had this type of genetically this type of cancer. And so now she didn't have breast cancer, but she chose to preventively get a double mastectomy because of this particular reason. Now, the reason they are working toward a vaccine for this one, and it's what's called therapeutic vaccine. It's not a preventive vaccine. And we'll get into that, the difference between the two. It's therapeutic in the sense that it just hits on a protein. That protein is alpha-lactalbumin. And so you're like, well, what the hell is that? Well, exactly. It is a protein that these type of cancers make up, and it's really selective for this particular type of cancer. And which is great because this is the most aggressive type of cancer. So if you can get a vaccine that can treat these cancers, man, that's a big win, because the women that have these cancers, even if you get it caught early on, the remission is not that long. Usually they will come back, and a lot of times, a lot of these patients, they end up passing after 5-10 years, just mainly because even if they've got great treatment, just mainly because it's pretty aggressive. The cool thing is this is focused just on that particular protein. And what it does is it focuses the immune system to utilize the T cells, which are the natural killer cells. The T cells do the work. They're the ones that go in there and fight anything that in your immune system. The B cells remember. Okay, so the B cells can recognize, oh, wait a minute, that is foreign. We need to get that out of here, whether it's an infection or cancer or whatever it may be. And then the T cells go in and they go and clean it up and fight and, attach to it and destroy those particular cells. This is very, very selective, and that's why it has to be. In fact, they're utilizing these type of cancer vaccines. Now, granted, still in the research basis, along with immunotherapy. Immunotherapy is very precise. It only allows you to treat usually a particular type of protein or cancer that it affects that. It attacks that. And so it helps in dealing with treating those cancers. What's the I always, we were joking before about hearing those little jingles with the pharmaceutical companies. Mm-hmm. Well, Keytruda, and I can't remember that one, but Keytruda is I believe is for lung cancer. That's an immunotherapy. And so they're utilizing that along with certain cancer vaccine trials that are allowing it to really, it's over 40% decrease in the recurrence rate.
What's the administration of this? How do they administer it? What type of vaccine would it be classified as?
Well, this one is a standard, like we were talking about, whether it's therapeutic or whether it's preventive. Now, let's kind of go into that. Now, really, there's two types of vaccines. Therapeutic is where it's actively treating after you've already had the cancer or you already got the infection, it goes in there and it actively treats it. It kind of works in concert with immunotherapy. Now, preventative vaccines are like the HPV, the human papilloma virus. Okay, that's what we give to kids. Now, that one works well because there are certain cervical cancers, anal cancers, and head and neck cancers that it prevents, mainly because when the virus goes in, if you've had that vaccine and you come in contact with that virus, then it will attach onto it and destroy the virus before it can even turn into a cancer. And so that's a preventive. And that's what's great about those type of vaccines. And eventually we want to have all of our type vaccines be preventive. So you never really get those particular cancers. But the reality of it is it's very difficult for that to happen. Okay. And, those type of preventive vaccines are utilized because they use a kind of the shell of the virus. And it doesn't have any genetic material. It's just the shell. So your B cells within your immune system recognize it, and then your T cells attack it. And so it develops these antibodies to these particular viruses. And so you go in, and so if you ever come in contact with it, it immediately destroys those particular viruses before they even turn into a cancer. Okay, which is great. Although that's great, and that's an awesome thing that's happening. It's very difficult when you're talking about very specific proteins that you can attack. And so that's why this triple negative type breast cancer is, with this new alpha-lactalbumin protein, man, it looks as though it's going to be able to recognize this type of cancer and kind of break it up or not let it flourish in the body and essentially kill it before it ever becomes something bad.
So so last time we were here, we spoke about AI and then the incorporation of that. What do you see as the potential for this in the future with like we said, the blood work and AI and the way that we could recognize patterns?
If you ever watched the Marvel comics or Marvel movies, you saw how Doctor Strange was able to kind of figure out 14 million different endings to what happened, and he found only one in which the Avengers beat Thanos. Okay, AI can do that, and you see how fast he's looking all kind of weird, looking at all these things, trying to figure out which one works, trying to find what future will work. Well, AI can kind of do that in a very obviously loosely way. It can figure out what we need to look for, how we need to look for it, what markers within the blood, tissue, or whatever can distinguish that, or find something that's only distinguishable. Those cancers have one marker that it can find. This is okay. If we affect this marker and we treat this, it won't ever turn into a bad cancer or turn into something that can kill that particular patient. And so AI is going to be able, it's going to cause these researchers to be able quickly to find ways and protocols to develop these type of treatments, vaccines being one of them, but also immunotherapy treatments. Like I said before, gene therapy is going to be huge because they're going to affect our DNA. And that's the same thing. Moderna, has a bad rap right now because of what it did with the spike proteins and mRNA, the COVID vaccine. Okay. Globally, there's about 60 trials going on with mRNA vaccines. And these are all for cancer, various cancers, glioblastoma, pancreatic cancers, even I think they're colorectal. There are a lot of different cancers. Obviously, breast cancer is the one that's mostly studied and best funded. And so that one's being worked on. And they've made more access or they've gained more territory in that particular cancer than the other cancers. But there's ongoing research going on and trials, all human, that are going on with these different types of companies that make mRNA, immunotherapies, as well as these type of therapeutic vaccines.